Assalamualaikum and hi, my name is Nurfadzira Binti Ahmad Tajudin. In this video, I will present my research proposal, which is the title is Postal Distribution, Case Study Ninja Van at Sungai Petani. Research background of this study. Nowadays, with the opening of the express delivery market, the market competition has increased. Therefore, the development of a fast postal and courier delivery service network that comply with the requirement of market competition is very important. In Malaysia, the National Postal Strategy (NPS) established a roadmap network for the Malaysian postal and courier sector to maintain the sector relevant in the nation's overall development. The postal network in Malaysia usually consists of more than one sorting centre, and the main sorting centre are mostly located in Kuala Lumpur, Malaysia. In addition, each state has at least one sorting centre based on the courier service available. One of the postal and courier services that customers prefer is Ninja Van. Ninja Van began in 2014, and it was the first logistics company in Singapore to provide real-time tracking updates. In early 2016, the company entered Malaysia, and then the service started cover West and East Malaysia. Problem statement. The problem considered in this study is postal distribution or courier service delivery, specifically the delivery service of an emerging postal company in Malaysia, Ninja Van. In postal distribution, the aim is to find the shortest path in delivering the package, given multiple customers to serve indicated by one package each customer, and multiple routes to take. This problem is formulated as Vehicle Routing Problem, VRP. Finding the shortest route to do delivery will solve late delivery by minimizing the length of the road. One of the causes of late delivery is the worker taking longer road for postal distribution. Other than that, merchants do not always notify the delivery company about the campaign, so they experience unpredicted surge in demand. When the demand is too high and lack of workers, the delivery will be late to deliver, and the worker will miss the package since the package will keep too long. This problem will affect customer loyalty due to the constant problem. Besides, it can affect customer satisfaction in using their service. Retailers, suppliers might get bad review from customers and affecting their company itself. It can affect the profit of the company. This figure example illustrates the location with minimum parcel. It illustrates the undirected distribution network of the Ninja Van Sungai Petani Sorting Centre to 7 locations. The Ninja Van Sungai Petani Sorting Centre is indicated by 0. In 1 is the Taman Arcade, 2 is Taman Arcade, 3 is Taman Delima, 4 is Taman Intan, 5 is Taman Nilam, 6 is Taman Nilam Sari, and 7 is Kawasan Perusahaan Ringan Bakar Arang. Objective. The main objective of this study is to minimize the length of the delivery road for postal distribution. Other specific objectives of this study are: first, to determine the optimal strategy for postal distribution. Second, to investigate alternative shortest route to take for postal distribution, if any. And lastly, to get an insight into the current strategy adopted by the postal distribution. Significance of study. Optimal strategy found can significantly reduce the operation cost, deliver the shipment on time, and possibly deliver more shipment in a day, since the road is shorter. Since the COVID-19 pandemic began, Malaysia experienced a series of lockdowns to prevent the spread of the virus. Therefore, the demand for delivery service higher than usual. One of the aims is to reduce late delivery of customers. Besides, it can guarantee customer satisfaction and loyalty since their package arrive in a shorter time. As for the company, good feedback attract more customers, keeping the company relevant and profitable. Lastly, the research will contribute to the existing literature and knowledge in this field of study and provide a guideline for further analysis. Scope of study. The study will focus on postal distribution at Sungai Petani, Kedah. The study will cover the solution for vehicle routing problem using the Dijkstra method. Additionally, the scope of this study is only for 1 month, April 2021, when the district Sungai Petani, Kedah is under Movement Control Order, MCO. Postal distribution. The postal and courier industry in Malaysia is positively shaped by the recent launch of the Economic Transformation Program (ETP). The courier industry is a growing market that could be worth 4 billion by 2020. Similar to other sectors, during this pandemic, the postal and courier industry is facing new challenges. Although the Malaysian courier market has grown at 7% per year, this industry faces numerous challenges regarding low profit margin, access to capital, technology adoption, and quality. Previous studies on postal distribution. Norton et al. 2012 studied postal and courier services and focused mainly on customer responsiveness. They proposed a model of service innovation and customer responsiveness. Customer responsiveness to the location of the road will result in customer satisfaction and hence increase the effectiveness. Song et al. 2009 proposed an algorithm inspired by new swarm intelligence named Road Planning Agent to solve mail distribution with the aim to achieve the faster mail transfer. The result that we get are the minimum transmission time limit. All post road used in the minimum time limit road, including adjacent road and newly opened road. All of these roads forming Shandong Express Mail Network. Besides, the proposed method can be applied to the optimization of the nationwide postal express mail network. Hollis et al. 2006 studied an integrated mail distribution problem. The mail distribution is the real-life data of Australian Post model as a multi-depot simultaneous vehicle crew scheduling problem. This new mathematical formulation is used with the heuristic vehicle routing algorithm to find the vehicle route based on set coupling with column generation. The purpose of this study is to find a low-cost set of vehicle route, vehicle schedule, and crew schedule based at numerous depots to deliver a given set of shipment within a 24-hour cyclical period. Data collection. The data used in this study are collected for one of the preferable Ninja Van Sungai Petani by one worker. The data is obtained by interviewing the manager of Ninja Van Sungai Petani, Mr. Muhammad Ehsan. The information was collected for only 1 month, which is April 2021, excluding the 2nd, 9th, 16th, and 23rd of April, since every Friday is the holiday for the workers. The data is about postal distribution in the area of Sungai Petani, Kedah. The minimum distance from Ninja Van Sungai Petani Shopping Centre to the location that the worker used for delivery is 5.3 km, and the maximum distance from Ninja Van Sungai Petani Shopping Centre to the location that the worker used for delivery is 9 km. The minimum parcel delivered is 19 per day, meanwhile the maximum parcel delivered is 155 per day. In addition, if the worker failed to deliver the parcel and they are done with their work before the end of office hour, they must return the parcel to the sorting centre. Besides, if the worker to deliver the parcel and end their work after office hour, they will return the parcel the next day to the sorting centre. Solution methodology. There are two subsections. First is mathematical formulation and second is Dijkstra algorithm. Mathematical formulation. The postal distribution problem can be formulated as the following: mid-integer linear programming MILP problem. The objective function of the problem is given by equation 1, where the aim is to minimize the road taken by all vehicles. Constraint 2 is to ensure that each customer is visited at least once. Constraint 3 and 4 are to provide the start and end node. Constraint 5 prevent vehicle from returning to V node after visiting VI element of set of customer. Constraint 6 ensure flow conservation. Constraint 7 and 8 are to handle the capacity. And lastly, the output formulation are the road assigned to the vehicles. Dijkstra algorithm. The Dijkstra algorithm begins at the node you provide the source node, and it analyzes the graph to determine the shorter path between that node and all other nodes in the graph. When the algorithm has determined the shorter path between the source and another node, that node is marked as visited and added to the path. The method is continued until the path contains all the nodes in the graph. As a result, the path connects the source node to all other nodes using the shortest distance possible to reach each node. The Dijkstra algorithm can use only graph with positive weight. This is because the consequences of the edge must be added during the procedure to identify the shortest path.